Okay, so we're going to be starting our biochem discussion with looking at water and what makes water so special. And the first thing you notice about this water molecule is that there are two hydrogens attached to an oxygen. And also you notice that there is a positive and a negative side. That is because water is polar. It has a slightly positive hydrogen end and a slightly negative oxygen end. In this particular drawing right here, it looks like an upside down Mickey Mouse, or you could flip it over and it would actually look like Mickey Mouse, one of my favorite characters. So what is the big deal about water? Well, basically in order to have life, you need to have water. And it is the most important and abundant biological molecule. So the chemical formula, two hydrogens to one oxygen. And they're bonded, covalently bond, a nice strong bond between these two hydrogens and this oxygen. And most of the properties, what makes this water molecule so important is because of its polarity and because of its shape. And this helps it to interact with so many other molecules. So that's really the gist of it, is that we need to know that it's polar, that it has this shape that's going to help it interact with other molecules. It also can break apart in itself. Basically, you can get water to disassociate, to break apart in itself. And when it does, you end up with these hydrogen ions, which are positively charged, and a hydroxide, which is an oxygen and the second hydrogen ion, and those are negatively charged. So when something has a high concentration of hydrogen ions in it, then it's said to be an acid, and if it has a high concentration of hydroxide ions in it, then it is said to be a base. This is what basically gives us our pH scale. So if you look up here on the pH scale, on the acid side, over here on the acid side, you're going to see that things that will it is lower. The numbers are lower. So when it's lower on the pH scale, it's going to be an acid. And these are things like, lemons and vinegar and hydrochloric acid. And, the stronger the acid, the lower the number. So down here on the, let me get my pen to work correctly. Oh, here we go. All right. Down here on this side down in here, the stronger the acid is, the lower the number. Okay. Then the alkaline, or this is also known as a base. All right, and on the base side, which are the higher numbers, and those are things that you usually think of, characteristic of a base is slippery, things like soap and bleach. Okay, and these have a higher number. And if you remember, we can go back one slide, and you see that those that are acids have a high concentration of hydrogen ions. Those that are a base have a high concentration of hydroxide ions. Okay, and so the lower the pH, again, just to reiterate what we just said. And also remember, a neutral solution, something that is neutral, has a pH of 7, so it would be right here. Whoops, right in the middle. No, maybe I can get it to work. Here we go. Right in the middle has a pH of 7, and guess what has a pH of 7? You guessed it, water. All right, see you in class, guys.